picking up where we left off, algebraic proofs also can be done with geometry. So this is part 2. The first thing you want to look at is your online textbook where it offers the postulates and the theorems. So you will need to be familiar with your segment addition postulate, which simply tells you that if you have a segment that's broken into parts, if you add those individual pieces together, you will end up with the entire segment. So AB plus segment BC will result in the total segment AC. That's what segment addition postulate means. Angle addition postulate, of course, you would have a picture of an angle. And in this case, it's the same type situation. You would have one angle that's added to another angle that will equal the entire angle. Angle addition postulate. We also talked about the reflexive, symmetric, and transitive. However, we talked about it when we had an equal sign. So if you have an equal sign, know that that's dealing with numbers. If you see a congruent sign, that is dealing with figures. So in this case, like that angle, that's a figure, so you would use the congruent sign. Algebraic proofs, we use numbers. Geometric proofs, we typically use the congruent sign, but we can use both interchangeably. You'll see in a few minutes, okay, once we do our examples. So this time, reflexive property of congruence, because again, we're using the congruent symbol. Symmetric property of congruence, same thing. And transitive property of congruence. Yesterday, we talked about the transitive property of equality, symmetric property of equality, and reflexive property of equality, and it had equal signs in it. It has the same concept though. So reflexive, I told you that it's like looking in a mirror. The exact same thing is on both sides. This time it's on both sides of the congruent symbol. Symmetric means that if angle 1 is congruent to angle 2, then if I were to swap those and put angle 2 first, it's still going to be congruent to angle 1. So that's what symmetric means. And then transitive, again, is segment PQ is congruent to segment RS. Segment RS is congruent to segment TU. So therefore, segment PQ has to also be congruent to segment TU. So notice in the middle, they both have segment RS in common. So therefore, they are in common. They're congruent to one another. That's what those properties represent. If I'm looking at it in terms of an example, I am looking at a statement and a reason column. This is called a two-column proof. So the first statement that I'm going to talk about is, first I'm trying to justify each step. So what I would do is I notice that this is a segment, so I am going to set up a segment LM plus MN is equal to segment LN. And this was the first one, this was the first postulate that I talked about, which is called segment addition postulate. And if I'm looking at the picture, what I wrote is segment LM, this part, plus segment MN, this part, will equal the entire segment LN. That's what segment addition postulate means. So if I know this, now what I can do is take the information that's shown above for segment LM, which is S plus 3, and then I would add what's shown for segment MN, which is 2S minus 1. And I would set it all equal to the entire segment length, which is 4S minus 7. Well, why did I do this? I just substituted. So this is called the substitution. And this time I have an equal sign. So substitution property of equality. That is on the other video if you need to go back and look at that one, part 1. Now what I would want to do is I want to combine my like terms. So over here I have 1s plus another 2s, that's 3s. I have 3 minus 1, so that's a positive 2. and that is 4s minus 7. What did I just do? I simplified. So simplify, that's what I'm going to write. I could skip that simplify step and I can actually just move on to the next step if I wanted to shorten how many statements and reasons that I have. So now what do I do? Well, I want to subtract 3 on both sides, 3s to be specific. And when I did that, again, what did I just do? Subtraction. And I'm just going to abbreviate property of equality because again, I have an equal sign. And now I just bring down what's left over. 2 equals 4 minus 3s is simply s minus 7. Well, what did I just do? I again simplified. So I write simplify. And algebraic proofs consist of just doing algebra. So that's what I'm doing right now. So now what I do is plus 7, and again, you do not have to have this many steps. You do not have to have simplify. You can just skip. You can show what your result will be. You don't have to show this portion of it. But what did I do? Addition, property of equality. And now I bring down 2 plus 7 is 9. I got rid of those over there. It's s, and that is simply me simplifying again. And I learned on the first part of the video, the algebraic proof part 1, that I can rewrite this as the variable on the left-hand side, s equals 9, and that is called the symmetric property of equality. And again, I am using the equal sign. So when I see the equal sign, I'm going to use property of equality. If I see a congruent sign, then I am going to use property of congruence. So I still use the same wording depending on what is happening in the situation. And this is what I was talking about we were doing a few minutes ago, segment addition postulate. That was my first reason. If you have 8 statements, you have to have 8 reasons. So make sure you understand that you have to have the same amount for both columns. So now if I have another, this is still geometry, however, it has algebraic expressions in it and an equation. So we're going to solve this like a algebraic proof. Well, that's what it is. That's what we're going to do. So the first thing is I look at my picture and I determine that, oh, okay, this is an angle. What do I know based off of the postulates that I just went over? I know that the measure of angle MAT plus the measure of angle TAH is going to equal the measure, the measure of angle MAH. All right, so let's look at that. The measure of MAT plus the measure of angle TAH is going to equal the entire angle, the measure of MAH. Okay, so why is that true? The reason it's true is because of the angle addition postulate that we talked about earlier. The next step is to look at your figure again and see what information is given that you can use. So for the measure of angle MAT, I'm told it is 5x plus 3. Well, the angle addition postulate says I have to add measure of angle TAH, so that's 2x minus 9, and then I have to set that equal to the entire angle, which over to the side tells me that it's 6x. Why did I do that? I just substituted. So this is called the substitution property of equality because again I have an equal sign. What do I want to do now? I just want to simplify it. So I have a 5x and a 2x, so that results in 7x. 3 minus 9, which is negative 6, equals 6x. What did I do? I simplified. So here you just say simplify. At this point, now I want to get x by itself, so I am going to subtract 6x on both sides. So again, I don't have to show that. I can just show the result, which would be x minus 6 is set equal to 0. So what did I do? I did the subtraction, property of equality. I was going to say that didn't look right. Property of equality. Okay, let's spell subtraction right. Okay, and how do I get x by itself? Well, I just add 6 to both sides, which will result in x equals 6. And I said add, so I'm going to do the addition postulate. Why do I want to say postulate? Addition, property of equality. Since I was doing algebra, this is still considered algebraic proofs, even though I'm using geometry with it. Now this one is an actual geometric proof. So there is no algebra in the problem. There is actually a figure with geometric language. So I need to understand the symbol for angles, ray, and of course we always measure our angles with degrees. And then here we go with this congruent sign. So let's get started here. This one, it's given as pre-populated. So I have to figure out either the statement or the reason that's left blank. This says given. So if I look at given, I have two options. Typically it's the first one. So that's what we're going to write. Angle LNE is a straight angle. How do I know that? Because the reason said that it's given. All right, so the pre-populated part told me then that the measure of that angle, LNE, is equal to 180 degrees. Okay, so what does that mean? Why is that true? Well, there's something called the definition of straight angles. So definition of straight angles tells me that that line, if it's a line, is going to equal 180 degrees. Definition of straight angle. Okay, now if I look at my reason, it says given. Well, I've already written the first one, so I'm going to look at the second one, which is ray NI bisects angle LNE. So that's what I write for my statement. Ray NI bisects angle LNE. And all the while, I'm also looking at my figure so I can see what they're talking about. So ray NI bisects means it's cutting it into two equal parts, angle LNE. So this is a straight angle because it forms a straight line. So from this, the next statement says, and I'm looking at everything above it, angle INL is going to be congruent to angle INE. And this is coming after I realized that I have a ray that bisects that line. So therefore, it's kind of delayed. Since I didn't use the reason here, I used given instead, so it's kind of delayed. What I'm going to use now is, well, why is this true? Because the definition of an angle bisector, that ray NI bisected this big angle, so that's the definition of a bisector. This is sometimes confusing for students. So you just have to really follow along with what's going on. So, well, what took place after those angles were congruent? If you ever see two angles congruent, the next step will be that they're also equal. So the measure of angle INL has to be equal to the measure of angle INE. And again, remember I said it's delayed. So now, well, why is that true? That's true because of the definition of congruent angles. Those angles are congruent. So therefore the measures have to be equal, and this is why. So if I go up now to the next one, the reason is the angle addition postulate. Again, I'm looking at what I've already written. So it is telling me that if I add two angles together, it will give me the total big angle. So I'm going to work with the angles that they gave me. So that means that the measure of angle INL plus the measure of angle INE, so INL plus INE will result in the measure of LNE. So I took both of those angles and I added them, set them equal to my original angle, which is the straight angle. And that's the angle addition postulate. So now my next step was given for me. Two measures of the angle INL would equal 180 degrees. Well, why is that true? Well, if I were to substitute the information in that was given, those two angles will equal 180 degrees. Okay, so then how do I go from 2M angle INL equals 180 to just 1M angle INL equals 90? What did I have to do to get this 90? I had to divide both sides by that 2. So division, property of equality. And then finally, if I'm on my last statement, I want to go back to what I am actually trying to prove. So this is what I'm trying to prove, that angle INL is a right angle. Do not write prove as a reason. That will never be a reason. So what you do write is what are you trying to prove, but you write that under your statement. So angle INL okay, my pen's acting up. Angle INL is a right angle. Well, why is that true? Again, if you look above and the statement here, it's telling you that the measure of an angle is equal to 90 degrees. So I'm proving that it is a right angle. Well, why is that true? Because of the definition of a right angle. Proofs are kind of difficult, so you have to practice. It's telling a story along the statement side. You just have to kind of see a pattern that's going on. And then your reasons they consist of definitions, postulates, and like substitution and things of that nature. So you definitely have to practice. And this one is, again, referred to as a geometric proof because it did not have algebra in it. I hope that helped you guys. So don't forget, please like and subscribe. Thank you so much.